Hello friends, welcome again. So in this video I've taken two questions of IIT JEE, one which was asked in 1984 and one which was asked in 1979. So just read the question once. It is actually a subjective question, but these days they don't ask. But this can be asked as multiple choice also. So there is all probability that it can come in this way. So they're asking A greater than 0, B greater than 0, C greater than 0. This is given. Then prove that A plus B plus C times 1 by A plus 1 by B plus 1 by C is greater than or equal to 9. This was asked for 2 marks. And the second question was show that for any triangle with sides ABC, and they have given one inequality which we are supposed to prove. And this was asked for 3 marks. So before I do this question, I'll teach you some small bit of theory with which we can solve this question within maybe 10 to 15 seconds. So that this concept is called as the Cauchy Schwarz Inequality. So let's see what this says. For any two real sequences AI and BI, I'll explain in a moment how to do this. We'll see the statement. Sigma, I mean summation of AI square times summation of BI square is always greater than or equal to summation of AI BI whole squared. So I'll consider two sequences now. Let's say a set of sequences, that is A1, A2, A3 and so on till AN. And I'll take another sequence, that is B1, B2, B3 and so on till Bn. These are my two sequences, right? So Cauchy Schwarz inequality says that A1 square plus A2 square plus so on until An square multiplied by B1 square plus B2 square plus B3 square so on until Bn square. These two are in multiplication is greater than or equal to A1 B1 plus A2 B2 plus so on until AN BN whole squared, right? So this is what it says. So to understand this a little more better, let's solve two small questions. When we get the basics right, then we can solve those two IIT JEE problems. So let's read this question. It's given that x square plus y square plus z square is equal to 1. That is given. So they're asking what is the maximum value of x plus 2y plus 3z. Now watch how I make two sets. This is only a play of making two sets, I mean two sequences, okay? Once you get to make this, then our work will be very simple. So let's see how to make the sets. Since I need square, I mean the square terms which is present in the general inequality, so one set will be x comma y comma z, right? And always remember the two sets should be of same size. You can't have one with 10 elements and one with 20 elements and then put inequality. If you want to put, then first 10 and first 10, like that only we have to put. So my first set will be x comma y comma z, and my second set will be 1 comma 2 comma 3. 3. So watch close now. I am going to apply Cauchy Schwarz inequality for this question. So it says that this square, that is x square plus y square plus z square, that is equivalent to this part times 1 square plus 2 square plus 3 square, that is equivalent to this part, should be greater than or equal to x into 1 plus y into 2 plus 3 into z, right? So x into 1 plus 2 into y plus 3 into z whole square. Don't you see we already got the answer? So this part they've already given as 1, so this doesn't matter, this is 1. And 1 square plus 2 square plus 3 square, that is 9 plus 4, 13 plus 1, 14. 14 is greater than or equal to x plus 2y plus 3z, right? That is whole square. So it's this maximum value is, if I remove the square, I have to put a square root over here. So our final answer will be root 14. So this is our final answer. So in this way we have to solve this problem using Cauchy Schwarz inequality. So let's see the next one. It's given that let a comma b comma c comma d be positive reals. That is the condition they are giving, such that a plus b plus c plus d is 1. And they're asking what is the minimum value of 1 by a plus 1 by b plus 1 by c plus 1 by d. Now be careful, don't go making sets as a comma b comma c comma d and 1 by a 1 by b like that, because that will bring the terms as 1 by a square plus 1 by b square, which we don't want. So what is the solution for that? So let's consider the sets root a comma root b comma root c comma root d. I hope you are getting that where I'm going in this problem. And the second problem is, second set is 1 by root a, 1 by root b, 1 by root c, and 1 by root d, right? So if I do this way, now I have got two sets. Now let's apply the Cauchy Schwarz inequality. So root a square, that is a plus b plus c plus d, after I square them, and times this square, that was equivalent to this part. Now this square is 1 by root a square, that is 1 by a, plus similarly 1 by b plus 1 by c plus 1 by d, right? Which is greater than or equal to first term of this times first term of this. The root a into 1 by root a is 1, right? Plus 1. This will be same thing, this will be same thing, and this will be same thing. 1 plus 1 plus 1 plus 1 whole square, right? And they have given also that a plus b plus c plus d is 1. Sorry. So this cancels out to be 1, and they're asking the minimum value. We have the same inequality here. So greater than or equal to 1 plus 1 plus 1 plus 1, that is 4. So 4 square, that is equal to 16. So in this way we get the answer. So I hope you understood the application of Cauchy Schwarz inequality. Now let's solve those two IIT JEE problems. So these are the two problems. So we had already read it before. So let's see. They're asking us to prove that a plus b plus c times 1 by a plus 1 by b plus 1 by c is greater than or equal to 9. So clearly you know that we have to take the two sets now as root a, root b, root c, and 1 by root a, 1 by root b, 1 by root c, right? So let's apply a plus b plus c times 1 by a plus 1 by b plus 1 by c is greater than or equal to multiplication of this plus this whole square. So that is 1 plus 1 plus 1 whole square greater than or equal to that is 1 plus 1 plus 1 is 3 square is 9, right? So it was actually proved in the previous, in the solution using AMGM inequality. Many of these inequalities are actually proved using AMGM or AMHM or such kind of things, but if we know Cauchy Schwarz inequality, it makes things really simple. So let's see what is the second question. And they're asking, show that for any triangle with sides a, b, c, 3 times ab plus bc plus ca is less than or equal to a plus b plus c whole square. I'll just write this the other way around, because that is what we know, a plus b plus c whole square. We have to prove this as greater than or equal to 3 times ab plus bc plus ca. Now let me consider two sets, a, b, c, and the other set I'll take it as b, c, a, right? I can take any sets, that's my wish actually. So if I apply the inequality, a square plus b square plus c square times b square plus c square plus a square is greater than or equal to multiplication of these two, that is ab plus bc plus ca whole square. So that is ab plus bc plus ca whole square. So this is these two terms are same actually, right? So I can write it as a square plus b square plus c square whole square greater than or equal to ab plus bc plus ca whole square, right? So I'll just remove the square terms by putting root on both sides, so that doesn't matter. So from this we have to arrive to this. So what I'll do, I'll add 2 times of ab plus bc plus ca on both the sides. So let's see what that gives us. A square plus b square plus c square plus 2 times of ab plus bc plus ca greater than or equal to, already one time is there, this is one time of ab plus bc plus ca. If I add 2 times of this to right hand side also, I'll be getting 3 times of ab plus bc plus ca. Don't you see that a square plus b square plus c square plus 2ab plus 2bc plus 2bc is nothing but a plus b plus c whole square. So that is a plus b plus c whole square is greater than or equal to 3 times of ab plus bc plus ca. So in this way, using Cauchy Schwarz inequality, we could easily prove, if this was asked as multiple choice, they would have given these options actually, maybe a plus b minus c whole square or anything like that. Since it was 1979, it was asked as a subjective question, but nowadays it is asked as MCQs. So, but still, concept remains as a concept only, right? So this was Cauchy Schwarz inequality. So you can solve more problems on this. it would have come maybe in many more years. I found two problems, so I picked them. So thanks a lot for watching this video, and please do like and share this video if you have learned something from it, and if you're new to this video, please do subscribe. So thanks a lot for watching this video. Bye guys.